In this example, we're going to look at the work shown in order to create equal bases when you have an exponential equation where the bases are not the same. So the first example, I have a fraction, so you just want to look at the denominator. So we're dealing with 64 and then on the right-hand side, 16. So when you look at both of those bases, you always start with the smaller 16. And you ask yourself, can you raise 16 to some power to get 64? So if I raise 16 to the second power, that would be the smallest exponent. That wouldn't give me 64. 16 squared is way higher than that. So we can't use base 16 here. So we have to go lower than 16, but whenever we pick a base lower than 16, we have to make sure that we can raise that to some power to get 16 again. So I wouldn't choose 8 because if I try to square 8, that's not going to give me 16. And I need to make sure that I can still apply a new base that gives me a value of 16. So we're going to be using 4 here. 4 squared gives me 16, and 4 to the third power gives me 64. So I can use base 4 here. So on the left-hand side of the equation, if you remember, the 64 was located in the denominator position, and we know that 4 to the third power is 64. So in order to get the 64 in the denominator, you just put a negative on the 3. So the left side would be 4 to the negative third. And the right side, how do I get 16 using base 4? We said it's 4 squared, right? So 4 squared, and that's raised to the 2a power. So those are equal bases. In the next example, let's take a look at our base. We have 27 on the left side, and we have 3 on the right side. So we always start with the smallest base, so 3. Can I raise 3 to some power to get 27? And the answer is yes. 3 to the third is 27. So the base we're using is 3. So on the left-hand side, how do I get 27 again? That would be 3 to the third power, and that's raised to the x plus 2. And on the right-hand side, the 3 was in the denominator. So that just means instead of 3 to the first power, right, which is just 3, how do I flip it to the denominator? You just add a negative to that. So it's 3 to the negative first, and that's raised to the x power. For this final example, let's take a look at the base. We have base 8 and base 16, so we always start with the smaller. Can I raise 8 to some power to get 16? And the answer is no, because if you take 8 and square it, it's already higher than 16. So I can't use base 8, so I have to go lower than that. But if I go lower, like if I pick 4, you still have to be able to use 4 as your base and get an answer of 8, because that's another base that we need, right? So if I square 4, that's 16, so I can't use 4 because I still have to be able to get base 8 out of that. So let's try 2. 2 to the third power is 8, so that works to get the left-hand side. And then 2 to the fourth power is 16, which is the right-hand side. So I could use base 2 here. So on the left-hand side to get 8, it would be 2 to the third, and that's raised to the y. And then on the right-hand side, how do I get 16? 2 to the fourth, and that's raised to the y plus 2.